We are going to try Hugging Face SmolVLM on Raspberry Pi 5. The whole process was not as straightforward as I expected. This is why I'm making today's video, to save you some time and headache. I had to put on my GitHub detective hat, read through a bunch of PRs and issues to find the fastest way to run the model, and then hack together a demo script that takes an image from the camera, a prompt, and outputs a text response through a separate speech generation model. The original 2 billion parameters SmolVLM was released in November 2024, and since then Hugging Face followed up with a few even smaller models, the 500 and 256 million parameter ones. At this size, the natural question is, are these models even capable of anything? Surprisingly, the answer is yes. According to benchmarks provided by the team, the original model performs better or equally well as compared to the other local vision language models, while having a smaller memory footprint. You can quickly check what these models are capable of in one of the web GPU enabled spaces on Hugging Face. My verdict would be that 256 and 500 million parameters models are good enough for simple use cases and can be made better with fine-tuning for very specific application. But alright, you tried it and it looks like it can work for whatever you want to do with the language model. How can you run it on a Raspberry Pi or a similar SBC? The model card only mentions the possibility of running it with transformers, which are not optimized for edge devices. Another way is to use the onnx runtime, since onnx files and sample inference scripts are provided. And this is the way I went first, only to discover it was slow. The token generation speed was okay, but the visual encoder took way too long. Even the integer 8 quantized timing was 35 seconds. It would mean that there is a 35-second delay between the input and model starting to generate the tokens. I expected better from SmolVLM, so I kept digging. Subscribe and hit the like button to keep digging with me. I don't know why I said that. The de facto standard way to run language model locally is Llama.cpp. You can use it standalone or as a backend in Llama, Cobalt.cpp, or any other wrapper. So it would be a natural choice to run SmolVLM on Raspberry Pi. Here comes a problem though. The architecture of SmolVLM IDEFIX 3 is not supported by Llama.cpp. And what is worse, the multi-modal support was removed from Llama.cpp server example a year ago during refactor and never came back. I fully understand Georgy Gerganov, the creator of Llama.cpp. He runs this open source project mostly by himself, I guess, and has pretty limited resources. In fact, he specifically mentioned that the multi-modal support for the server example is looking for contributors. If you have the time and skills, this could be you. Not all hope is lost though, because there is an ongoing PR that refactors the Vision API and adds support for a few more Vision models, including SmolVLM. After some trial and error, I was able to successfully convert and run the models. However, the example there was a simple command line inference, where you provide a single image and a prompt and get a single text response back. It's okay to try the model, but likely you will want to load the model once and then send your images and prompt to it. I wrote a simple sockets-based application and an example Python script showing how to interact with it. Big disclaimer time. All of this is work in progress based on another work in progress. Changes might and will happen to the pull request. Be ready to do debugging if something doesn't work. It's tested on Raspberry Pi 5 and x86 MacBook Pro. If you want to try the model and my script right now, start by git cloning my fork of Llama.cpp to your PC. Create a virtual environment with virtual env or conda. Install the dependencies for the model conversion there. Clone the model repository from the Hugging Face. And run the conversion command. Now you have the gguf file, which you can transfer to Raspberry Pi. On your Raspberry Pi, again, git clone my fork of Llama.cpp. Copy that gguf model file into models directory under Llama.cpp. I already have it. Configure CMake with the following command. And build Llama Vision Socket application. In the second terminal, you can run the Python example, which is located under Llama.cpp, examples, vision. You will need OpenCV Python installed to run that demo script. Start the Llama Vision Socket application with the model path specified. Takes a little bit of time to actually get started. Okay, now we see server listening on temps vision sock, which means we can run our Python script now. Press enter to take a picture and then wait for the language model output.
The image features a person, though only their face is fully visible. The face is that of a man with short, neatly combed hair. His expression seems serious.
Very serious. If you run with the useTTS argument, it will use piper-tts to speak out the output of the language model. You need to install piper-tts as well for that. Language models get even smaller than this. Watch me running one on ESP32 inside of a robot Dalek. Or if you need more power for running your language models, take a look at this board, which looks very much so like NVIDIA Jetson, but it is not.